Hey guys, Miss Dyer here, and this video is for Friday, August the 28th. This is the last new topic that we need to talk about in Chapter 1 in getting ready for your test, which is going to be on Monday. Again, on Monday, we're going to have our Unit 1 test. It will be a timed test. You will only have a certain amount of time to complete it. So it's very important that you make sure that you have studied and that you are pretty familiar with all the material in this unit. I actually also have posted, I think I posted yesterday a Unit 1 test review, and I'm also going to be posting a video today where I'm going to go over that Unit 1 test review. So make sure you take a look at that and make sure you email me and let me know if you have any questions before your test on Monday. So the last thing that we're looking at in Unit 1 is called accuracy and precision. We want to look at, these are two words, we want to look at what do they mean. Because when you hear the word accurate or you hear the word precise, a lot of times we kind of think they mean the same thing, but they really don't. And we have the definitions of those two words right here on this page. Accuracy refers to how close you come to the right answer. So accuracy, and again, we're looking at these two words in terms of measurements, like when we're doing an experiment, we're making measurements. Accuracy refers to how close you are to correct. So we're comparing the measurement that you got to the actual correct measurement. How do I know what's correct? How do I know what the right answer is? Well, when it comes to our measurements, we would have to know what the right answer is either by our teacher telling us or by us looking it up in a book or a chart. Like, for example, if I was trying to measure and calculate the density of an object, you would make your measurements and do your calculations, and you would come up with a certain density that you measured for this object. Well, how would you know how accurate you were? Well, you would have to determine how accurate you are by comparing the density that you measured to the actual density of the object. So how would you know the actual density of the object? Well, either I would have to tell you what the actual density of the object is, or if you knew what it was made of, you could actually look the actual density of it up in a book or online. So the right answer has to be given to you. You don't know what the right answer is until it's either given to you by a teacher or out of a textbook, or the question. If you have a question, the question is going to have to tell you this is the actual answer, the right answer or the actual answer. So how close your measurement is to the right answer or actual answer, that's the accuracy. Precision refers to how close each of your measurements are to each other. Okay, so with accuracy, we're comparing our measurements to a given answer. With precision, we're comparing our measurements to each other. The closer our measurements are together, the more precise they are. The closer our measurements are to the actual answer, the more accurate they are. So a good way to visualize this is to look at a bullseye target, okay? Let's consider that the dark circle here in the center is the right answer. It's where we want to be. We want to be at the very center of this target, of this bullseye. That's the right answer. Then the little white circles are our measurements, okay? So if you look at this right answer and you look at our measurements, notice how they're all close to the right answer, and all our measurements are pretty close to each other. So here in this picture, our measurements are accurate because they're close to this right answer, and they're also precise because they are all close to each other.
Attention teachers, before you go home, if you are interested in any COVID-friendly packaged watermelon, you can go down to Miss Lee's room. Have a great day.
Go get you some if you want some. Okay, look at these measurements. Notice that these measurements are really not that close to the right answer. Here's our measurements. Here's our right answer. They're not really close to that right answer, and they're kind of close to each other, but not really. So for this one, I would probably say this one's not accurate because they're not close to this right answer, and it's not really too precise either because they're not close to each other. Moving on to this one. Okay, we see here that some of our measurements are close to the right answer, so they are accurate, but they're all not close together, so they're not very precise. So we have some accuracy here, but not precise. Then we look at this picture. Again, these measurements are all close to each other, so they are precise, but they are not really close to the right answer, so they're not accurate. So not really accurate, but they are precise because they're close to each other. So you can see here that you can be precise, but not be very accurate. So let's look at a couple of example problems. The first one here, you measure the density of an object 4 times. You get 2.5, 2.8, 2.9, and 2.6. The actual answer, the actual density is 2.7. So look at these measurements. Are they pretty close to the right answer? I would say yes. Are they pretty close to each other? I would say yes again. Between 2.5 and 2.9, that's pretty close. There's a difference of 0.4 there. All of these are pretty close to 2.7. So I would say that these measurements are accurate and precise. Accurate because they're close to this right answer, and precise because they are close to each other. Okay, let's look at the second question. Measuring the volume of a liquid. We got 120.0, 120.1, 120.3, 120.9, and 120.5. The right answer is 129.9. Okay, so are they accurate? I hope you said no, because the right answer is 129.9. 120 is not very close to 129 at all. It's quite a bit off. It's, about over 9 milliliters off here. So that's not very accurate because they're not close to this right answer. But are these measurements precise, meaning are they close to each other? Are all 5 of these pretty close to each other? Well, we have a span of, the lowest one is 120. The highest is 120.9. So the difference between the highest and lowest is only 0.9. So that's less than a milliliter. So yes, I would say these are pretty precise. They're close to each other. These numbers are all close to each other. But they're not accurate because they are not very close to this right answer, which is 129.9. Okay? So again, accuracy is being close to a correct answer or actual answer, which is given to you in the problem. Precise is comparing the measurements to one another. If they are close together, they're precise. If they're not very close together in terms of the amount, then they're not precise. Okay, so you do have an interactive notebook over accuracy and precision to turn in to me today by 5 p.m. Now, again, also remember your formal lab report is due today by 5 p.m. So again, you've already had since yesterday when we did our Google Meet to finish that. If you were with me at our Google Meet, you should have pretty much gotten that close to being finished. So make sure you get that completed and turned in to me today by 5 p.m. And then also that interactive notebook is going to be due to me today by 5 p.m. as well. Hope you have a great afternoon, and we'll talk to you soon. Bye-bye.